this section we're going to talk about humidification. Now, most people feel very comfortable in a pretty narrow range. We like our temperature to be within, between 72 and 80 degrees Fahrenheit, and we like our relative humidity to be between 40 and 60%. So air conditioning is the way that we keep ourselves comfortable. We keep our occupied spaces within that range. Humidification is a way of increasing the relative humidity. So by increasing the amount of water, the amount of moisture in your air, you increase, your relative humidity. It's P sub V over P sub G, or P sat at T. So what you're trying to do is you're trying to increase the partial pressure, the numerator. So by increasing the partial pressure, by increasing the amount of moisture in the air, you're effectively increasing the relative humidity. All right, so the way that you do that is you just inject water into the air. And there are different methods of doing that. Here I've just shown we're injecting it in. So we're spraying either a superheated vapor or a liquid into that moist air as it flows through the ductwork. And depending on whether or not you're injecting a high temperature steam or you're injecting a liquid, that's going to affect what's going on with your temperature. So down below, what you see is sort of just kind of a quick and dirty sketch, I guess, of what the psychometric chart looks like. So you can see that if you inject a high temperature steam, a vapor, then your temperature at state 2 is going to increase. But if you inject a liquid, then of course your temperature is probably going to decrease. And if I look at the moist air coming out of this thing, of course my specific humidity is obviously going to increase because I have more moisture in the air. All right, so what I'm going to do is I'm going to draw my control volume so that I've got essentially two inlets. I've got the water being injected, and then I've got the moist air flowing in, and then I've got one outlet where the moist air is flowing out. So if I apply my mass balance, I'm going to do it for each of the components. So for the air, it's going to be the same as it has been for the simple cooling and for the dehumidification. The mass flow rate of the air coming in and out are the same, and so we just call that m dot A. Then I'm going to apply my mass balance for my water. Now here, I've got two inlets for my water and one outlet. So if I apply my conservation of mass, what I'll see is I've got m dot V1 and m dot W coming in, and then I've got m dot V2 coming out. So if I apply my conservation of mass and then I rearrange this to get an equation for m dot W, what that's going to give me, I'm going to kind of rearrange it, try to get m dot A, isolate that guy, so I can put that m dot W in terms of the change in specific humidity. Now I'm ready to apply my energy balance. So if I apply my energy balance, now up until this point we've had heat transfer, but the way that I've drawn my control volume here, I don't have any heat being transferred. Yes, I may have a temperature change, but that's affected by by adding water in the form of a high temperature steam or a liquid. So the way I've drawn my control volume, I don't have any heat transfer, I don't have any work, I don't have any changes in kinetic and potential energy. So all I've got are the sum of the m dot H's coming in and out. So I'm going to write that as 0 equals the sum of the m dot H's coming out minus the sum of the m dot H's going in. I could certainly reverse that if I wanted to, but I'm doing out minus in. Okay, so I've got dry air coming out, dry air coming in. And then my water vapor, I've got water vapor coming out minus water vapor coming in, and that's not accounting for the injected water, which I'm just going to call for the time being m dot W, and the enthalpy of that HW. So I'm going to kind of do the same thing as I've done before. I'm going to try to isolate m dot A. So I know m dot A1 and m dot A2 are the same, so I'm going to take that on the outside of the parentheses for that dry air term. Not going to do anything with the second term there, but this last term, m dot W, I'm going to replace that with the definition that I found by applying my mass balance. So looks like everything's pretty good here. Now I'm going to rearrange that second term. well, yes, I'm going to rearrange the second term, but I'm going to divide everything through by m dot a. So if I divide the right-hand side by m dot a and the left-hand side by m dot a, well, the left-hand side is still going to be 0. Yep, this is what I've got, m dot a divided through, and I know that m dot v over m dot a is just my specific humidity. So yeah, looks like, do I have everything? I think I've got everything. The only thing that I might take an issue with is the enthalpy of the injected water, because that's going to depend on whether or not you're injecting a superheated vapor or a liquid. So if it's a vapor that's injected, you can approximate that as H sub G at the temperature that it's injected at. And of course, with a liquid, you can approximate that as H sub F at the temperature that it's injected. So once I do that, and I'm going to just kind of rearrange this so that I have things in terms of the specific enthalpy of the moist air. And that way, if I wanted to use my psychometric charts to solve this, I could. All right. Well, I hope that was helpful. Thank you for watching.